Okay, minasan, konnichiwa, Zamurai Engineer desu. So in this live stream, we'll talk about DWV system. What do you mean by DWV system? So that is about our engineering utility, which is called D as in drain, W as in waste, and V as in vent. So DWV system. And before we start, I would like somebody to confirm our sound check. Okay, clear. So therefore, let us start. So, what is a DWV system? So before this meeting, we already talked about water supply system. So we familiarize ourselves with the water supply system. Now, we would like to familiarize ourselves with DWV system or DWV piping. So as you can notice on your screen, you have a picture on the right side of the screen with yellow arrow. So the first arrow refers to the vent. Okay. So the second arrow. So the first arrow, that is the highest arrow. The next to the highest arrow, that is pointing to drain. Okay. So drain pipe, and the third arrow, that is the stock pipe, and the fourth one, that is pointing to trap, and the fifth one, that is pointing to a clean out. Okay, so those are some of the common components of DWV pipings or system. Drain pipes use gravity to carry wastewater away from fixtures, okay, appliances, and other drains. This wastewater is carried out of the house to a municipal sewer system or septic tank. Very common application in our country. Usually, we do not have a municipal sewer system or treatment plant in our municipality or city. We have an individual septic tank for each of the building. Drain pipes are usually plastic or cast iron. In some older homes, drain pipes may be made of copper, galvanized steel, or lead. So we already talked about what are the materials for water supply. Now, these are the materials that are in direct contact with waste. Okay, so there are a lot of bacteria, not only bacteria, but a lot of impurities. Okay, so those impurities and bacteria and minerals may react negatively to our material. So that's why we need to choose proper type of material. Because they are not part of the supply system, lead drain pipe pose no health hazard. Okay, so we are not choosing lead to water supply system because lead is a toxic material, meaning poisonous. If lead enters our human body, it is dangerous. Okay, health hazard and may result to sickness, disease, or even death. Okay, So, lead pipes are no longer manufactured for home plumbing system nowadays. Okay, usually galvanized steel or even the conventional steel pipes. Okay, drain pipes have diameters ranging from 1 and 1/4 inches to 4 inches. Take note of the sizes. Okay? These large diameters allow waste to pass through easily. So take note of this, 1.5 inches. So almost 1.5 inches is almost the biggest water supply. The common is 1/2, 3/4. That is the most common size of water supply. But when we are talking of waste, we need more cross-sectional area. Okay? So 1 and 1/4 to 4. Usually, we are using 3 inches and 4 inches. Okay? Traps are an important part of the drain system. Okay? This curved section of the drain pipe called standing water, and they are usually found near any drain opening. Okay? So, the standing water of a trap prevents. So, this is the function of a trap. Okay? That's why they are important. The standing water of a trap prevents sewer gases from backing up into the home, preventing bad or foul-smelling gas to be consumed by human being. Each time a drain is used, the standing trap water is flushed away and replaced by new water. So we are free from bad or foul smell. That's why when somebody is inside the toilet or CR, it would be better if even if you are not, even if they are not yet done, okay, pooping, okay, taking a poop, even if they are not yet done taking a poop, it is better to flush right away to discharge immediately the foul smell. Okay, so that is the right way if you don't want to smell those bad smelling gases. Okay? But the usual procedure is they are taking their poop, and after completely done taking a poop, that is the only time that they flush or they wash the water closet. That is the only time that the waste, including the foul smell, would be taken away from the room, from the toilet and bathroom. Okay. In order to work properly, the drain system requires air. So we are now talking now of drain system. Air protects trap from being drained. Okay, that is the one function of drain. There is always a minimum amount of water trap inside the trap. Okay, so that's why it's called trap, because a small amount of water, the desired amount of water is trapped, and that is important because it prevents bad smell to get out of the pipe and go inside the habitational area, okay, of the occupants. Okay, so to allow air into the drain system, drain pipes are connected to vent pipes. All drain system must include vents, and the entire system is called drain waste vent system. One or more vents located on the roof provide the air needed for drain waste vent system to work. And that is what? Vent. Okay? So that pipe. Okay? One or more vents. Okay? One or more vent pipes. So just like in your screen, the figure on your screen at the right, you have what? At least two vent we have a vent pipe and we have the stack. And the stack includes both the waste and vent. That's why there are at least 2 vents in your figure, in the diagram, in the picture. Okay. Okay. This is a picture of a cross section showing the parts and location of the different components. On the lowest portion, starting from the lowest portion, you can see the septic tank, the pipe, rather, not the septic tank itself, but the pipe going to the septic tank, or the pipe going to the municipal sewer. Okay. I think there's a city neighboring our city, that is Muntinlupa city. They have already started to build. I don't know if they already finished the municipal septic tank or municipal sewer. They have a treatment facility in Muntinlupa. Okay. So in our city we do not have, and what we are doing is individual septic tank for buildings, and after how many years? 3 years to 5 years, the method is to take out all the soil inside the septic tank. Okay, using what? Pump, using equipment, and connect a hose going to the truck. Okay, so there is an assigned truck to roam around our city in order to do that kind of job. Okay, so it will suck out all of the soil from the septic tank and out to the truck, and the truck will deliver it to the waste area, or the assigned area for that purpose, for that disposal. Okay. The next that you can see on this diagram is building drain. Just like what I've said, that portion is the building drain, wherein it is the main drain system of the building. Okay, it is a very short component, very short horizontal component, a very short the connection connected to the horizontal component. So that is what we call building drain, very short component. Okay. And next to that, from below, the third one from bottom is waste stack. Waste stack is like a stack pipe. Waste stack is actually stack pipe. The difference that stack could include both waste and vent, but when we call it waste stack, it only involves waste. There is no vent. So connected to it, as you can see on this diagram, connected to it on the upper part. So this is the waste stack. Connected to it, this one is our vent going up. Okay. So the next to waste stack is what? Branch drain. When we say branch drain, that is what we call horizontal. That is horizontal part. That is horizontal drain. Horizontal drain we call branch drain. And the main drain, that is building drain. That is very short, vertical, connected to the horizontal part, going out to the area. Okay, going out to the building, going out from the building. Okay, so the next to it on the side is what? Drain pipes. Okay, so there are drain pipes here. So there are drain pipes 1, 2 in this figure. So drain pipes again. These are very short pipes that is connected to the horizontal branch drain. So horizontal, they are called branch drain. Okay, drain pipes, short vertical drain system connected to the horizontal. Okay, similar to building drain. So, but drain pipes, they are connected to its fixture. Okay, so next one, we have a trap. Okay, so we have P-trap, actually. So there are several types of trap. There are P-trap, S-trap, and so on. U-trap or but nowadays the most popular and I think the only one being used is P-trap. Okay, so this is the P-trap connected to, for example, sink, lavatory, and so on. Okay, and we have the stack. So stack pipe is what we call a vertical pipe. So in this case, this is actually vent stack. Okay, vent pipes. Okay, vent pipes. These are the what we call vent pipe. So the pipes connected and above the fixture. Okay, connected. So going out in order for air to be introduced into the system. So if the air are introduced into different paths inside the system, it is better in order to avoid clogging. So we have a clogging or reverse direction. Sometimes the direction of water would flow in reverse because of clogging. That's why we need vent in order to introduce water from the atmosphere inside the system in order to prevent clogging. Okay. So next, you have the picture on your right side or in your middle. Picture in the middle is showing us how to install. Okay, so you have the flooring. So you have the provision hole. That is a hole. So this pipe would go down below this floor and upward. So we are just using what? A branch here. There is a branch that we are going to connect. So this is a connection. Okay. So this is this connection is T. In this manner, usually the connection is Y. In our country, mostly Y connection. Y is better because it is not very susceptible to clogging. So T connector may be clogged in this location, in this 90 degrees. In this 90 degrees part, they may clog. So that's why we usually implement the use of Y connection rather than T. Use vent T fittings only in vent pipes, not in drain pipes. Okay, so T connection only in vent pipes. That is the reason why we are using this. That is to prevent clogging. So meaning vent pipes do not have solid or liquid particles inside it. That's why it is called vent. Its purpose is mainly for the introduction of air. Inside the vent pipe is either air or fresh air or the foul smelling air or gases. Okay, there is no solid or liquid portion. So we can use what? T. Can use T. So meaning since it is T, so we can expect that this pipe is actually stuck vent. Okay, vent pipes. Okay. So drain pipes must maintain a minimum 2%. This is actually written on the code. 2% slope that is not supported by a T with the perpendicular pipe outlets. So minimum slope 2%. Okay, what do you mean by 2%? 2% means 2 centimeter for every 1 meter. So 2 centimeter slope for every 1 meter. That is 2%. Common sewer pipe materials, PVC or ABS, they are allowed for use in DWV system. So they are both what? Plastic. Okay. Cast iron is also allowed but is rarely used in residential construction. So for waste drain and vent, we are usually implementing the use of plastic. Okay. Either PVC or ABS. They are both what sufficient and economical. Okay. Drain and sewer pipe general requirements. Number 1, install fittings that have a smooth interior surface. So again, in order to prevent clogging, because clogging is not immediately being experienced. It is what? Aggregate of dirt. It is an aggregate of dirt that would clog a pipe in the long run. For example, after months of use, after years of use. So, and accumulation of dirt is being accelerated by what? By interior surface that are not smooth. So, if the interior surface of the pipe are rough, with rough surface, not smooth, so it is what? It will collect dirt and later on it will what? Clog the whole pipe. Okay. So example, do not use ABS fittings with PVC pipe. Okay. So that means we need to only use compatible with the pipe to which they are attached, because if not, those connectors will increase the possibility of dirt, soil being trapped in that region. Okay. If the connectors is designed for each other, meaning they are compatible with each other, the designer of that connector will make sure that there is a minimum possibility of dirt, soil to be trapped in that region. Okay. So do not use fittings that contain ledges, shoulders, or reductions that may retard or obstruct drain flow. That is what I'm trying to explain. So ledges, okay, shoulder. So those are sections with possibility of dirt to be accumulated. Okay. Number 3, install fittings that maintain a 2% slope, okay, and are approved for use where installed. Example, do not use a venti in a drainage pipe where water flows. So that is for proper flowing of water, and flowing of water means flowing of waste with soil, okay, with solid particles. Okay. Number 4, do not use threaded connections in pipes where the threads run on the inside of the pipe and could retard or obstruct. So that's why do not thread the pipe more than necessary. Okay. So there are pipes that you have to thread it manually by yourself. So it is much better to use a pipe that are already threaded from hardware. Okay. So number 5, do not drill, okay, tap, burn, or weld drainage, sewer, and vent pipes. Example, do not drill into the vent pipe to insert the discharge hose from a water softener. Okay. So we have to prevent this. Okay. So instead, use connectors. Okay. Use connectors rather than doing it by yourself. Okay. So the purpose of you drilling, tapping, burning, or welding is you want to connect something into it. And then, therefore, You just have to what? To cut the pipe into the correct length and put on the necessary or suitable connector, elbow, Y connector, T connector, and so on. Okay? And number 6, do not choose the following types of joints and connections. What are those? Do not choose cement or concrete joints. Do not choose mastic or hot pour bituminous joints. Do not choose fittings not approved for the specific type of pipe or installation. Do not choose joints between different pipe diameters, made elastomeric rolling O-rings. Do not choose solvent cement joints between different types of plastic pipe, and do not choose saddle fittings. Okay? So, most and almost all of these have something to do in relation with the prevention for collecting the dirt and clogging the system. Okay? So, these are the general requirements, and these general requirements you can put this on as the note or guidelines on your plumbing plan. Now, let's go to common DWV pipe material. You may use any of the common drainage and sewer pipe material listed in table 33. So we will take a look at the table. You may also use other materials listed if approved by your local codes. What are those? So we can check there in our law, in our plumbing law. So NPCP. So in PCP we have the listing of approved materials and brands, okay, or material, okay, different types. There are listings of approved. Okay. Number 2, install galvanized steel drainage pipe at least 6 inches above the ground. Okay. So when you are using steel galvanized drainage pipe, okay, you have to install it at least 6 inches above, because galvanized surface would react to certain types of material, minerals, and so on. Okay, so galvanized surface is only effective against oxygen or oxidation, okay, to prevent corrosion of the material. But if it reacts to other minerals and elements on the ground, so it would deteriorate its property. So this is the listing of approved materials, okay, for drainage and sewer pipe. Okay. So we have cast iron soil pipe. Is that okay for drainage? Yes. For sewer? Yes. Okay. So what is the difference of drainage to sewer? Okay. So drainage is dominantly liquid. Sewer is a mixture of solid and liquid. Okay. So common drainage sewer pipe materials. Next type is ABS. Okay. So used for drainage, yes. Used for sewer, yes. So it can be used. Next type is PVC. Used for drainage, yes. Used for sewer, yes. So the fourth type of material is steel pipe, either black or galvanized. Okay. So the black one is the most economical one, because galvanized pipe is a little bit expensive. They can be used for drainage but cannot be used for sewer. Okay. So next topic, water closet connection between closet flange and pipe. Okay, how to connect our toilet bowl. So technically, toilet bowl is called water closet. Okay, you may use 3-inch water band to connect to a closet flange if you install a 4" by 3" flange to receive the closed fixture horn. Okay? You may use 3" quarter bend. Quarter bend. Okay? Quarter bend meaning 90 degrees. Okay? So, you may use. Okay? So, 3". Usually, we are doing this in our country. That is also the code. 3". Okay? So, install a 4" by 3" flange. Okay? So, meaning to say, if you install a 4" by 3" flange, meaning to receive the closed fixture horn. So, if you are using a 3", then it could be connected to the 4". So, that's why the flange is 4" by 3". Okay? And you may use a 4" by 3" reducing closed bend to connect to the closed flange. Okay? You may. Okay? So, reducer. Okay? Reducer. So, 4" by 3", reducing closed bend to connect to the closed flange. So, either that, one into connecting to the closed flange and pipe. Okay. What about tail pieces? Number 1, provide sinks, waters, laundry tubs, and similar fixtures with tail pieces and traps. Okay. Tail pieces, this is a very short pipe, okay, that is connected to the fixture and to the P-trap. Okay. So, tail pieces and traps at least 1.5 inches in diameter. So, that is the minimum size of tail pieces. Okay. Number 2, provide vanity sinks, bidet, and similar fixture with tail pieces and traps at least 1 1/4 inches. Okay. So, for sinks, okay, dishwasher, laundry tub, okay, minimum 1 1/2. Vanity fixture 1 1/4. So a little bit smaller, no? A little bit smaller. Slip joints. Use slip joints only on trap inlet, outlet, and within the trap seal. Okay, that is the use of slip joints. And number 2, provide access to slip joints with access of at least 12 by 12 inches. Okay. So, access, meaning when you want to clean it up, when you want to maintain it up, you want to replace. So, we need an area for that type of repair job. Okay, or technical operation. Okay. So, this is what we meant by 4" to 3". 4" by 3". Okay. Reducing closed bend. Okay. This is also called horn. Okay. So, this is quarter bend. This is what we call quarter bend. So, although it is 90 degrees, it is not a 90 degrees with respect to the actual corner. It is bended like this. It is bended. Okay? There is a smooth transition from this line to this line. There is a smooth transition. Not 90-degree transition. There is a smooth transition in this bend connector. Okay? So, this is 3 inches. This is the 4 inches. Okay? Chrome P-trap. Chrome P-trap is material. We are referring to the material. This is chrome plated. Okay? Usually chrome plated. this is not actually pure chrome or a chrome pipe, but only chrome plated. Okay, after some time the plating will flake off, and this will become what, corroded. Okay, but this is P-trap with slip joints on lavatory sink. Okay, what do you mean by slip joint? This is what we call slip joint. This one. Okay, slip joint. This one. Okay, so slip joint, to be able to easily disconnect and connect, disconnect. That is what we mean by slip joints. Okay, so slip joint. So drain tail pieces. Okay, so drain tail pieces must match the diameter of the other pipes in the drain kit, 1 and 1/4 or 1 and 1/2. Okay, so depending on the type of fixture being drained. Okay, so for vanity fixture, that is 1 and 1/4. For most common fixture, that is 1 and 1/2. Okay, so tail pieces. Violation: flexible rib material is not approved in drain waste vent system. So using this type of material is not approved. Okay, it will add to the risk of clogging. Okay, that will add to the risk of clogging. So I think this is the what, hot water, hot or cold water. Okay, so you can have that type of water supply. Okay, for example, hot water. So you have to connect it to an electric supply, make it hot, or you can see it. So cannot confirm right now what is this. It could be a pump, it could be a cooler, it could be a heater. So okay, it could be a this is not supply line, so my bad. This is what? This is a fixture that collects waste. So for example, it could be a grease collector. Okay, okay, grease collector in the kitchen, from the kitchen. Could be a grease collector. Okay, so we have this one, so that the grease will what? Will clog it up, so that when we need it, we will heat it up, so that the grease will be liquefied. So the grease will solidify in cold weather. Okay, so that's why we need to heat it up, so that it could go on to the what. And some of it, sometimes there is a what, the reservoir collector of grease waste, so that it could be taken out from the building by manually, no, a manual operation. So sometimes that is the case. So this is not a supply of water, so this is not a heater. This is heater for example, for grease, to make the grease liquefy. Okay, so these are smaller pipe, these are the water supply, but we already talk about that. We are talking now of this pipe. So these pipes are mostly plastic, because they are smooth interior side, no? So minimal possibility to clog. Okay, that is, so this is not approved. So how can we describe the fittings? So for example, elbow or bend. So bend, we already know what do you mean by bend. They are used to change direction. They are available as single fitting into openings. They are available also as double fittings, okay, with 3 or more openings. So that is what we mean by single or double. Okay. Some bends have inlets in addition to the openings. Okay. Use bent bends only in the dry bend section of bent pipes. Quarter bends are sometimes called short sweeps in plastic pipe because we are learning, familiarizing about different types of names and convention, because if you want to order that part from the hardware, if you say uh, do you have short sweeps, what, somebody from the hardware may not even be familiar with the name short sweep. They are just elbow. If you say elbow, everybody in the hardware will understand it. Okay? Everybody in the hardware will understand it. But if you say bend, sometimes there are 1, 2 person that may not understand it. Okay? Closet bend. Okay? A fitting used to connect a closet part. Flange. Closet flange. So that's why it is called closet. Meaning water closet. Okay? So closet bends often reduce the pipe size from 4 inches of the closet flange to 3 inches. That is standard for the closet flange. 4. That's why we need to make it 4 by 3 flange in order to reduce, okay, to 3. Okay. But if your pipe is 4, so you don't need to reduce. Just by the 4 by 4 flange. Okay. Okay. So closet flange, the fitting upon which a toilet or the water closet sits. Okay, that is the fitting. It is being fixed. This closet flange is being fixed on the flooring. It's being fixed on the flooring. Many different closet flanges are available to accommodate different fittings and pipe configurations. One type of closet flange allows you to offset the closet flange around the floor joist because it is being fixed on this flooring. That's why if the flooring is made up of wood, we have what? Wood joist or floor joist. So we need to offset it on this component of the flooring. Okay. Coupling, what do you mean by that? It is a fitting used to join 2 lengths of pipe in a straight line. That is what we call fitting. It could be male or female. Or rather, it has 2 female openings, 1 on each end. So female opening, so that means the pipe have to be inserted inside the coupling. That is what we mean by female opening. So coupling is a female opening. If you say male opening, that is union. That is what we call union. Okay. So okay, coupling is female. Inlet, an additional opening in a fitting. A low heel inlet is located in a straight line with 1 opening of the fitting. A high heel inlet is located above the curved portion of the fitting. A side inlet occurs on one side of the fitting. Sanitary T. Sanitary T is a T fitting combined with a 1/4 bend fitting. So 1/4 meaning quarter bend or 90 degrees bend. Okay? That is what we call sanitary T. Okay? This is T in T form. Okay? That is T form. So sanitary T is a T fitting combined with, so there is a combination, okay, of a T fitting and a bend. Okay? Straight Street fitting. A street fitting has a female opening, what we call hub. That is a female opening. Here, female opening, the pipe, you have to put the pipe inside it. This is the hub. Okay? So, on one end, in the male opening, spigot. Male opening is what we call spigot. And female opening is hub. Okay? On the other end, most drainage fittings have female openings on both ends. Okay? Because it is not susceptible to what collection of dirt and accumulation of dirt, and later on, finally, it would be clogged. Sweep. Sweep is a drainage fitting used to make a 90 degrees change in the direction of flow. Sweep. Short sweep, that is elbow. Okay. Sweep is a fitting 90 degrees. Short sweep is the same as quarter bend in plastic pipe. So short sweep is only for pipe. Short sweeps and quarter bends are different fittings in cast iron pipes. A quarter bend with a longer radius bend is sometimes called long sweep or a long turn quarter bend. Okay? A T. A T is a fitting with the 3 openings. 2 openings are in a straight line. Okay? So we already done this. Okay? So what do we mean by tailpiece? This is the tailpiece. This is the tailpiece. So tailpiece. Okay? So this tailpiece must match the other pipes in the drain kit. So we already. So next we have one Y. What do you mean by Y? A fitting with 3 openings also. Okay. So let us look at the figure at your center of your screen. Bend pipes, the different bend pipes. So letter A is what we call one port. This is one port or quarter straight bend. Quarter straight bend. Not straight. Quarter straight bend. I usually hear in the construction site straight bend. They are saying straight bend. That is straight bend, not straight. This is pronounced as straight. Okay, one port straight bend, and then letter B, one port bend. Okay, one port bend, one port straight bend. Okay, and then C, one port bend, one port bend. Okay, so bend is almost 90 degrees. This looks like almost 90 degrees. Okay, so this is straight bend because there is no hub. This is what we call hub. This portion is hub. This one, letter B, there are 2 hubs. Hub and hub. They are called female openings. This one and this one, they are both female openings. This is female opening, this is male opening. This is hub, this is spigot. Okay. Can somebody confirm how to pronounce spigot? Is it the correct way to say the word? Okay, so I will confirm how to say the word. For too long, I am not worried about having a mistake in
spigot.
Okay. The correct way, as I confirmed, is spigot. Spigot, not spigot. So, I am using the word spigot. Okay? That is spigot. Okay? So, the correct word is spigot. So I have used that mistake for too long, okay, so spigot. Okay, so letter C, hub on both openings. So hub in both openings. But this is another hub. So there are 3 openings, 1, 2, 3. They are all of them are hub opening. So take note. It is clear that we have what hub in this opening here. So we have the interior what stopper for the pipe. So the pipe that you will be putting in must be pushed up to this point. If not, the dirt would collect in between and it may cause you to be clogged after some time. So the pipe should touch this thing, this stopper, okay? Or up to that point, that is the stopper. So the pipe should be pushed up to that stopper, okay? So the pipe should touch the stopper. So, for example, this is spigot. So this spigot should touch this inside portion, the stopper. Okay. So this is what we call 1/4 bend with side inlet. So with side inlet. Table 34, bend direction. We can buy 90 degrees, 60 degrees, 45 degrees, and 22 and 1/2 degrees. This is 116, 1/8, 1/6, 1/4. So 1/4 bend, that is 90 degrees. Okay? 1/4 bend. So 1/6 is, we can solve this one, no? So we can solve this because this is 90 degrees is pi over 4. Pi over 6, that is 60 degrees. Pi over 8, that is 45 degrees. Pi over 16, that is 22.5 degrees. Okay? So that is why it is called 1/4, 1/6, 1/8, 1/16. Okay? So next, so we have parts of a water closet drain system includes closet bend. So this is the closet bend. This is 4. This is 3. So the 4 is connected to the closet flange. What is the closet flange? This is the closet flange. This is the flange that you have to fix on the flooring. You have to fix it on the flooring, and where you have to connect the bowl. You have to connect the water closet itself to this flange. Okay? You have to connect by what? By seal and what? Cement paste. And you have to fix this to the concrete by using pins or bolts here. There are bolt holes here. Okay? And then underside, at the bottom here, the lower part, you have to put this 4 inches. This is standard 4. And then reducer, this will become 3 inches here. Okay? And letter C, that is offset closet flange. This is offset closet flange. If ever there is a situation wherein this flange or the toilet bowl would be directly looking at directly on top of the what do you call that of the joist. If that is directly on above the joist, you have to use this one, offset closet flange, instead of this one. Next, we have what? T. Letter A. This is letter A. This is double fixture T. Okay, so this is T. So double fixture T. And letter B, vent T. This is vent T. It is allowed to be cornered at 90 degrees. It is allowed to have a corner 90 degrees. Okay? Meaning, the curvature of 90 degrees is not smooth because vent, air will travel inside it, so it will not clog. It will not clog. Air will just travel inside it. So, unlike this one, as you can see, there is what? There is a smooth transition from 90 degrees to the what? From horizontal to vertical. Okay? There is a smooth transition. Okay? And letter C, test T. This is just a test T. Okay? So, Y. Okay? Inlet fittings include vent with low heel inlet. So, low heel inlet. So, this is a low heel inlet. So, quarter bend. This is not a Y. This is the Y, but this is not actually Y. This is sanitary. This is what we call sanitarity. Okay? Single sanitarity. This is double sanitarity. The same as this one. This is a double fixture T. But double fixture T is more on fluid or liquid. But here, double sanitarity is actually more on solid waste with water. Okay? With water. Okay? Sanitarity, double sanitarity. Okay? And this is what we call vent with side inlet. The same with previous example. Okay, we have Y fitting. This is what we call Y. So unlike the sanitarity, this is just a sanitarity. Okay? It is not a Y. Okay, so this is Y. Fittings for DWV use include Y, double Y, TY. So TY. Okay? So T and Y combination. This is double Y combination. So this is the single Y. So or Y. Okay? So tables, approved fittings, listing for changing flow direction. You can have by 22 degrees, 45 degrees, 60 degrees, okay? 90 degrees. Okay? Where do you want to use it? So 22.5 degrees, then horizontal to vertical direction, vertical to horizontal, horizontal to horizontal. You can use it in all of those things. Okay? What about 45 degrees? You can use horizontal to vertical, vertical to horizontal, and horizontal to horizontal. What about 60 degrees? Okay? You can also use in all of those orientation. What about 90 degrees? You can use it for vertical, for horizontal to vertical, but for vertical to horizontal, yes, for fixture drains with equal or less than 2 inches. No for other pipes and sizes. Okay? That is for vertical to horizontal. So, vertical going to horizontal. Vertical to horizontal, we cannot use that type of 90 degrees. Okay? For greater than 2 inches. Okay? Okay? So, what else? So, those are the things that we need to familiarize with. Okay? For example, sanitarity. Horizontal to vertical, yes, limit on multiple connection of fittings. We cannot use it on any other orientation. Horizontal to horizontal, no. Vertical to horizontal, no. We can use it horizontal to vertical. So, meaning horizontal going vertical. Okay? With limits on multiple connection of fitting. How about Y? We can use it in any orientation. Because Y is the most efficient, effective for DWV system. Okay, what about 90 degrees elbow for plastic pipe? Okay, there is a limitation for vertical to horizontal horizontal to horizontal. So that is what? For size of 2 inches and above, it is not recommended for use. Okay. Okay. So that's all for our main topic. Next topic would be drain and sewer, pipe connection and joints. Okay. So please give me 1 minute, and I will also drink some water and look at your question. Are there any question before we go to the next subtopic? Yeah. Okay, there are no questions. So let us proceed. So if there are questions, you may use our comment box below, and I will try to look at it every now and then so that I could reply on your question. Okay, let us proceed. So we have the next subtopic is about drain and sewer pipe connections and joints. As you can see on the picture on your screen, you have the changing flow direction from vertical to horizontal. So from vertical, meaning here is the drain or waste stock. Okay, so waste stock going here. This is Y. Okay, and it is very efficient and effective in changing the direction from vertical to horizontal without much obstruction and trouble of clogging. Okay, so this is what we call one-fourth bend. Okay, one-fourth bend. So 1/16 bend is a little bit, just look like this. That is 1/16. 1/8, 1/4. Okay, so 1/4 meaning one-fourth. Okay. Okay. So 1/6, 1/8, 1/16. Okay, so it is what? From one-fourth, it becomes straighter, no? Gradually straighter. So this is 1/8 bend. So we want to familiarize ourselves. Again, take a look. Drain and sewer pipe connection and joints. How to connect the drain and sewer. So this is the drain or sewer. It could be the drain or sewer. Connect with this, connect with this, connect this one. Okay. Okay. So how to connect with what? This is TY. This is what we call TY. Okay. Also a good connector. Minimum obstruction. So from vertical to horizontal. Okay. So we have two 1/8 bend. So 218 bend is equal to 1/4. So 1818 is equal to 1/4. So meaning you can use a single 1/4 bend here, but using a single 1/4 bend would involve additional risk of clogging. That's why we use 1/8 bend here. Okay, and as you can notice, there is a noticeable slope here. There's a noticeable slope. The slope here is not noticeable. There is a slope here. This is not perfectly horizontal. There is a 2% slope here. Okay, much like here. But it is not noticeable. You cannot notice it. But here, it is noticeable. Maybe because this is more than 2%. But you can use more than 2%. The minimum is 2%. You can use more than 2% slope. Of course. Okay? Minimum is 2%. That's why I would assume that this is more than 2% because it is noticeable. This is not noticeable slope. Okay? Long sweep. This is what we call long sweep. So the curvature is longer. That is what we mean by long sweep. The curvature is longer. Short sweep if the curvature is shorter. Okay? So using a long sweep, changing flow direction from horizontal to horizontal. Horizontal to horizontal, both of this. This is horizontal, this is horizontal. But this has a 2% slope, this must have a 2% slope. Okay? So horizontal to horizontal. Okay? Next. Okay? So from horizontal to horizontal, using a long radius TY fitting. So TY fitting here can be used in horizontal to horizontal. Okay? Let's familiarize ourselves. Okay? So it is noticeable. The slope is noticeable, but this is a bad slope. The slope should be reversed. The slope should be going down here, not going down here. Going down to the right, not going down to the left. This is a bad slope. Okay? The correct way is like this, going down to the right. Because this is what? This is a sanitarity. Okay? Sanitarity meaning there is a presence of soil and solid plus liquid here. So this must be what? Sloping downward, going to the vertical. But this is horizontal to vertical. So from horizontal to vertical, horizontal must be sloping down, going to the vertical. Okay, this is wrong. Okay, the slope is wrong. Okay. B is 1/8 bend. C is Y connector. Okay. So Y fitting. Okay. So drainage in sewer fitting for changing flow. Use fittings in table 35 to change the direction. So we have a listing again. Then next, drainage and sewer pipe fittings, changing from horizontal to vertical using multiple fittings. Okay. So you may use multiple fittings and double fittings, whichever is required. Okay. Number 2, do not use a double sanitarity to receive discharge from back-to-back toilets and from. This is not allowed. If there are 2 water closets and you use a double sanitarity, that is not allowed. Okay? Okay? You may use double TY. You can use double TY but not double sanitarity. The most popular way and accepted one is use double Y. Double Y, it is approved for use. double Y. Okay. So next, quarter bends with heel or side inlet. So we already know what do we mean by this. We already saw the picture. So you may not use a heel inlet quarter bend to change flow direction from vertical to horizontal. If the fitting serves a toilet, you cannot do that. You may use a heel inlet quarter bend to change flow direction from horizontal to vertical without restriction. If that is the case, from horizontal to vertical. Number 2, you may not connect wet vented fixture. What do we mean by wet vented fixture? Vent is for gas. Vent is for air. Why it is wet? Because there are vent pipes that is also used for waste. Double purpose. There is a vent pipe that is also used for waste. That's why it is sometimes called wet vent. Okay? So you may use, number 3, the side inlet of quarter bend to change the flow direction when the inlet is horizontal or side facing. But when the inlet is vertical, facing up, the side inlet may accept drainage flow from any fixture except a toilet. So mainly, toilet would clog this thing if you use it vertically. Okay? You can use it in any other way. Okay? So side and heel inlets are usually 1.5 or 2 inch openings, and you may not connect a toilet to any openings less than 3 inches. Take note, this is code. This is written on our NPCP. So it is written on NPCP. I know you are assigned to have a copy of NPCP. I assign you to have a copy of that. So you can take a look at that document, and this is the code. This is the minimum size that could be connected to water closet. Number 4, you may connect a dry vent to the quarter bend side or heel inlet only when the inlet is vertical. Vertical and it is only dry vent, so it is okay. So what are those different allowed uses of 90 degrees bend? Okay, summary. This is the summary. 90 degrees bend with low inlet heel. So like this. This is the inlet. Inlet. Flow from any fixture except toilet. You cannot do this. Okay. So if you use wet vented fixture, okay, no vent connection. Okay. So 90 degrees bend with high heel inlet, flow from any fixture except toilet. Okay. Vent connection. Okay. Flow from any fixture except toilet. So meaning you cannot use it for toilet. You cannot use it for toilet. So this one and this one. Okay. 90 degrees vent with side inlet, flow from any fixture. Okay. Vent connection. Okay. So you can use this type. This particular inlet. This particular inlet. How about this one? You cannot use this side for a toilet. No vent connection. Okay, here. Okay. So next, flow from any fixture. Okay, vent connection. Okay, in this side. So you have to familiarize yourself. You have to take this one by one in order to familiarize. So flow from any fixture except toilet. Here, we cannot use that as toilet, but we can use this side. Okay. Flow from any fixture except toilet. Okay, vent connection. Okay, so this one cannot be used. Okay, most probably this one due to the size, because they are not 3 inches. Okay, so this one is okay for toilet. Okay, so this one is not. This one is not. Okay, so what about the last one? Flow from any fixture except toilet. So we cannot use toilet here. Also, flow from any fixture, okay. Vent connection, okay. So this one could be connected to toilet. Okay. What about sanitarity? What are the allowed flow direction change for sanitarity? This is the sanitary flow direction. Okay. This is the sanitarity. Okay. So this is the sanitarity. So the direction of flow should be going there. So this is not okay. This arrow is bad. No? This is a bad example of flow. This is the correct flow going from right to left. This is the right flow growing from above to left. Growing from left to right or growing from growing from right to left and going from right to down. Okay? This is not correct. You do not design this from this point and going to the right. Okay? That is not correct direction. This direction is correct. This direction is correct. I don't know why. So the correct direction is from right to left. The correct direction is from vertical to left. From right to left. So there is some error here. So 90 degrees bend allowed direction change. You can do this. So there are so many FB groups that have this planning group problems. They are posting problems and you can check if they are okay or not. You can check it. Okay. So long and short sweep. Okay. So this could be long or short sweep. Any size, any pipe. Long sweep, okay. Any pipe, any size. For this long sweep, because it is coming from this Y. This is a Y connector. This is a Y fitting. This is a Y. Okay, this is Y. This is 90 degrees. Okay. The correct slope is going down here, not going up. The correct direction is going down. The correct slope. P-trap, going up, correct. Then going down, going down, going down, going down. This is sanitary. Okay, sanitary. This is what? Fixture drain. Okay, fixture drain. This one, fixture drain. Okay. Any question? There are no questions. So I may proceed a little bit further. So next topic, subtopic is about drain and sewer pipe connection and joints. Okay. Drain, sewer pipe connection and joints. So plastic pipe joints. So approved by elastomeric gasket, meaning plastic gasket to joint buried ABS pipe. So that is number one. Number two, you can use solvent cement to join the ABS pipe. Okay. And number three, you may use threaded joints. Okay. So those are the things that we can use for plastic joints. Next, steel joint. So steel joints, you may use threaded. Okay. The thread should be NPT. Okay. Okay. National pipe thread. NPT meaning national pipe thread. Okay. Number two, you may use approved mechanical joints. Okay. So there are several types of mechanical joints. Okay. So you may also use the approved design. Okay. And next, PVC plastic pipe joints. How to join those plastic. You may use approved elastomeric gasket, same as in ABS material, PVC material, PVC joint. Okay. So do not Do not mix up. So there are different types of plastic. Use the proper or same type of plastic material. Okay. So number 2, you may use solvent cement to join pipe. Number 3, you may use threaded joints for Schedule 80 and heavier. Schedule 80 is thick plastic. So 40, a little bit thinner. 60 is on the middle. So usually what we are using is 40 and 60. Mostly 40. Okay. And next, joints between different types of pipe. So if we are going to join different pipe material, use compression or mechanical sealing elastomeric fitting. Okay, compression type. Number 2, use an approved brass ferrule with a cork joint or mechanical compression joint. Okay, cork joint. So let us see. If we have picture, so we have what? PVC green cement. So I know white cement. I know but green cement, this is my first time to be encountering a green cement. First time for me to encounter green cement. I don't know what to expect. Okay? So PVC green cement, because this is for joining PVC, so it will be most likely what? A paste, no? Number 3, use brass converter fitting for the electric fitting. Okay. Next, how about drain and sewer pipe slope? Again, so install horizontal drainage sewer pipe with uniform slope and alignment. All of these pipes must have a slope. Number 2, install pipe not more than 2.5 inches diameter with at least a 1/4 unit in 12 units or 2% slope. Okay. So minimum, that is what we mean by at least. So the word at least means minimum. Minimum 2% slope. So install pipe at least 3 inches diameter with at least 1/8 unit in 12, so 1%. Okay. So for bigger pipes, for 3 inches pipe and above, we can use 1% slope. But for smaller pipes, 2.5 inches diameter pipe and below, use 2% slope. And next, drain and sewer pipe size reduction. So, reducer. So, you can also use the reducer as enlarger. Okay? So, do not reduce drainage and sewer pipe size in the direction of water flow. Okay? You can use enlarger rather than reducer. Okay, so another picture for cement. So, can we say that this is a blue cement and what silver cement? So, the same brand of cement being used in United States. OT ABS to PVC green transition cement. This is what? PVC cement, OT cement. This is ABS. So, this is ABS material. This is PVC. Okay. Use the correct solvent for the type of pipe you are using. PVC and CPVC should be welded with PVC solvent. Okay. ABS requires ABS solvent. Okay. So, they are different from one another. So, you use the appropriate type of paste. Okay. Cast iron pipe joints originally were made with hub fittings. So, where are the hub? This is what we call hub. This location, this is called hub. Okay, that is the hub. This is what we call hanger. Pipe hangers. Okay, so this is hanger. Hook type hanger. Hook type hanger. So, this is not perfectly horizontal. This must be 2%. So, this is more than 3 inches. Now it is allowed to be 1%. So 1% for this one because this is more than 3 inches. Okay. So installing in support DW. This is wrong again. This is DWV. DWV, not DBW. Typo error. So typo error. Okay. So now let us go to the next topic. Drain and sewer clean out openings. So this is the last one I think for the day. So clean out. What do you mean by clean out? So clean out location and spacing. So they must not be more than 100 feet. Okay, from another clean out. So they must be installed. 100 feet is about what, 30? This is about 30 meters. So every 30 meter, that is maximum. Okay, so it is better to have more clean out. So that you have more provision, more flexibility for what? Maintenance and cleaning. Okay. So install at least one clean out for every horizontal pipe drain. Okay, regardless of pipe length. So for every horizontal one, because the horizontal pipe are more susceptible to clogging because they may not be able to move the waste inside them. So while vertical, they are able to move the waste inside because of gravity. Okay? So that's the reason why. So every pipe dip, regardless of length. This provision applies to building drain, building sewer. Building drain, building sewer, they are short. They are very short. Okay, less than 10 meters. Less than 5 meters. They are less than 5 meters. They are even less than 3 meters. Okay? So building drain, building sewer. The horizontal branch drains and not to fixture drains. Okay? So fixture drain is different. So for fixture drains, you can use this standard. Number 2, install a clean out within 10 feet of the building drain and the building sewer junction. So as immediately as you can see the junction, use clean out within 10 feet. 10 feet is 3 meters. Okay, you have to use clean out within 3 meters of the building drain and building sewer. You may install this clean out inside or outside the building. Make this clean out accessible. Measure the 10 feet along the developed length of the pipe from the clean out fitting to the building drain and sewer. So measure that. So about 3 meters. That's why I said building sewer and building drain, they are very short. They most likely be less than 3 meters. Okay? Then therefore you have to use clean out. Number 3, install a clean out at every change of pipe direction that is more than 45 degrees. If the pipe direction is more than 45 degrees, use clean out. When multiple direction changes occur in one pipe run, only one clean out is required. So, okay. So one clean out if there are multiple directions. Space not more than 40 feet apart. This provision applies to the building drain, building sewer, and horizontal branch drain. Okay. So what about the clean out size? What is the size? Use the largest pipe served by the clean out. Install clean outs that are the same size as the largest. So use that, the largest pipe size. That is the same size as the clean out. You may not choose 1.5 inch fixture drain as a clean out for 2 inch. So must be the same size. No? You may install a clean out in a vertical stack that is one pipe size is smaller than the stack pipe size. If you are using what? Stack. Stack vertical, we mean vertical. That is what we mean by vertical. Stack. Okay? So if the clean out is connected vertically, so you can use one pipe smaller clean out because it is easier to clean the vertical pipe rather than the horizontal. Clean out accessibility, provide at least 18 inches between the clean out and any obstruction so that a human being would be able to access it during cleaning. Okay, 18 inches. So meaning 1.5 feet. 1.5 feet. Okay. So 1.5 feet, that is only 1.5 feet. That is the length. Provide that for accessibility. Number 2, do not conceal cleanouts with permanent finishing materials. Okay. Do not conceal. Okay. So extend underground cleanouts to or above finished grade. Do not extend cleanouts above surfaces where they may become trip hazard, okay, or where they may be damaged by traffic. So this is what? Very logical, okay? Meaning, do not use clean out, do not install clean out when there is a provision for what? For access space, okay? That is an access space. Do not use clean out there. Use clean out. Place it on the other side, for example. Clean out plugs. That is the cover. That is what we call the cover of the clean out. Okay? So that is the plug. That is the cover. Install brass or plastic plugs in clean out fittings. Number 2, make clean outs gas and liquid tight. So this must be tight. Not allowed to what? To penetrate or to leak bad smelling gases. So that's why we need to make that plug tight, okay? Liquid tight and gas tight. Clean out direction. Install clean out so that they open toward the direction of the waste flow. So the waste flow is going from right to left. That is the waste flow. So install clean out here so that it is in the reverse direction of the flow. So this clean out, the flow is there. So that's why if you use what? Rod. If you use a rod, you can what? Clean the horizontal pipe inside it. Okay? So next, clean out fixture connection. How? Do not connect other pipes or fixture to an existing clean out unless you install an alternate clean out. Okay? Do not remove clean out plug and use clean out opening as the drain or for a laundry. That is not for that purpose. That is only for access, for cleaning purposes. That is not for flowing of water. Okay? Clean out is a threaded, removable cap positioned in a drain pipe. Run to allow access for equipment that clears clog. Every horizontal line should have a clean out that is no smaller in diameter than the largest drain pipe in the line. So clean out. Seal clean out plugs before capping clean out fitting. So put a seal here, okay, along this, so before you seal it out. Okay. So there are two types of plug, clean out plug. This is one type of clean out plug. Okay. There are two types of it. So this is what? A clean out. For your convenience, keep access clear to clean out. Position movable objects like this washing machine so that they will not interfere with drain cleaning tools. Okay. Permanent obstruction must be kept at least 18. So that is what we mean by space provided for the human being that will do the cleaning. Okay. So measured perpendicular to the opening. So this is the opening, perpendicular to it. So give a space 18 inches from this. Okay? So 18 inches perpendicular to this. This is the space. Okay? So that ends our discussion of our DWV. The correct word is DWV. Drain, waste, vent. Not DVW. So it must be DWV. Drain, waste, vent. Okay? So that is our last
And I do not see any question. So I will just post the instruction on our GC. Again, this is Dr. AP, Preaching Engineering for Nation building.